Hello, this is lecture number 2 on control system. In the lecture number 1, we have seen the basics of control system. What is a control system and types of control system, closed loop and open loop control system, and examples. Now, in the second lecture, we will see the Laplace transformation. Laplace transformation is required to find the transfer function. So, what is a transfer function? We will see later. First, we will see what exactly the Laplace does. So, now Laplace transformation. Laplace transformation. The basic definition of Laplace of any function in terms of t, that is 0 to infinity e raised to minus st f of t dt. This is a basic equation of Laplace. Actually, the Laplace converts differential integral equations into simple algebraic equations. Simple algebraic equations. And second point, it converts S domain, time domain into S domain. Time domain into S domain. We will see how the Laplace functions both the points. The first point, it converts differential integral equations into simple algebraic equation. It converts a time domain into S domain. Okay, so we will take one small example for a time function, because this is the main disadvantage of Laplace. It requires only a time function. For example, I will take example f of t equal to 1, that is t raised to 0. So Laplace of 1 is equal to integration of 0 to infinity e raised to minus st 1 dt. So integration of e raised to st is equal to e raised to minus st divided by minus s, upper limit is infinity, lower limit is 0. Now I will take minus 1 by s is common, and e raised to st infinity 0. Minus 1 by s, e raised to infinity minus e raised to 0. Minus 1 by s, that is 1 by infinity, that is 1. So finally, that is 1 by s, finally it is what? Minus 1 by s, 0 minus 1, that is 1 by s. Means what? Laplace of 1 is equal to 1 by s. So like this, we can find a Laplace of any time domain into s domain. For example, Laplace of t equal to 1 factorial divided by s square. Correct? Next, a Laplace of t square is equal to 2 factorial by s cube. Very important, Laplace of t raised to n is equal to n factorial divided by s raised to n plus 1. Okay. So we will find the Laplace of e raised to minus at is equal to what? 1 by s plus a. 1 by s plus a. Now Laplace of sine of, before that I will go for Laplace of t raised to n, e raised to combined t raised to n and e raised to minus at. So Laplace of e raised to minus at is s plus a, t raised to n is n factorial divided by n plus 1. This is a combined of these two. And Laplace of sine of omega t is equal to omega by s square plus omega square. Omega is a constant. Okay, cos of omega t equal to s divided by s square plus omega square. Two more important Laplace, these are required in the control engineering, are a Laplace of e raised to minus at combined sine of omega t, that is equal to s plus a whole square plus omega square, numerator omega. The Laplace of e raised to at cos of omega t equal to s plus a whole square plus omega square, and here s plus a. If you put in this case, for example, a is 0, put a is 0, you will get the same equation. Here also if you put a equal to 0, this is e raised to 0 is 1, here s square plus omega square, you will get the same equation. Okay, these are the standard formulas required in control engineering to find a transfer function. So now I will define what is meant by transfer function. Apart from this, the important Laplace is d by dt is s, d square by dt square is how much? S square. D cube by dt cube is how much? S cube. And integration of dt is 1 by s. It converts integral equation into simple algebraic equation, there is 1 by s, and differential equation into simple algebraic equation, d by dt is equal to s, d square by dt square is equal to s square, d cube by dt cube is equal to s cube, and integration of dt is 1 by s. Okay. So now I will define what is meant by transfer function. So it is similar to the efficiency. Efficiency is equal to output divided by input, but here the transfer function slightly different than efficiency. So it is a mathematical modeling. Actually, it is a mathematical modeling. What the transfer function gives us, it is a mathematical modeling of a system. Mathematical modeling of a system. If you take any system, if you are doing a mathematical modeling, that is nothing but transfer function. What it gives us, it correlates between input and output. It gives an equation with output divided by input, the Laplace of output divided by Laplace of input. Then definitely I go on changing the input, then it gives the output after taking what? Inverse Laplace. So transfer function, how to define a transfer function? Now it is defined as Laplace of output to the Laplace of input with initial conditions are 0. We will consider initial conditions, then the transfer function becomes complexity. At the UZ level, that is the initial conditions are 0. So now I will show what are the initial conditions. Now I will explain transfer function is equal to Laplace of output divided by Laplace of input. Okay, so now I'll take one example. We are understanding what is meant by transfer function, and initial conditions are nothing but there is a hysteresis in the system is 0, or stress in the initial tension in the system is 0, and even mercury in a thermometer, the mercury level we are assuming it as 0. So we are neglecting all the losses and all the hysteresis and stresses, some initial wear and tear, everything we are neglecting. Okay. So now I will take one example of transfer function. For example, RC circuit is a very basic circuit, RC circuit. So the question is to find transfer function of RC circuit. Okay. So this is a basic electrical system like spring mass system or a spring mass. Then so first of all we'll see the basic circuit, that is R, and this is a C. C is a capacitor, you know, R and C. Here the input is voltage in a function of time. I can vary the input so that I have written in terms of time. So output is also varying, but other rest of the parameters R and C are always constant. R is in ohm, C is in farad. Okay. So now here the input is, find the transfer function means what? Laplace of output divided by Laplace of input, means the transfer function is equal to Laplace of output divided by Laplace of input. This is the output, this is the input. So this is supposed to find. We are supposed to find this. So here we have to apply the Kirchhoff's second law. Kirchhoff's second law, because here I cannot apply any Newton's law. If it is a mass and all, then I can apply the Newton's law. Now, okay, depends upon the system. If it is the tank system, then we will apply the discharge equation and all. So here the input voltage is equal to voltage across resistor plus voltage across capacitor. Here no inductor. So first equation I will write input voltage is equal to voltage across resistor plus voltage across capacitor. You know the basics from basic electricity. Voltage across resistor is Ri, and voltage across capacitor is 1 by C integration of I dt. Okay. These two are the resisting elements. Even all three, inductor, resistor and capacitor, resistance resisting for the motion of electrons. So here if you see this, you get an integral equation. How to overcome the integral equation? Taking a Laplace transformation. We know that integration of dt is how much? 1 by s. So now t equal to, I will write s. Okay. Taking a Laplace transformation, vi of s is equal to, r is a constant. Okay, I cannot take a Laplace for r is outside, 1 by c. Integration of dt is how much? 1 by s, and I of t becomes I of s. So vi of s is equal to I of s r plus 1 by cs. So now I'll write vi of s is equal to I of s into bracket rcs plus 1 divided by cs. This is equation number 1, because I want v naught. So here you see that there is no any v naught term. So how to get a v naught term? I'll write, I suppose to write one more equation. So what I'll do, I'll write, you see that here the output is nothing but voltage across capacitor. The whatever by multimeter also, if you measure here, output voltage is nothing but voltage across capacitor. So that I'll write output voltage is nothing but voltage across capacitor. Voltage across capacitor. Voltage across capacitor. Now I'll take a Laplace transformation, v naught of s equal to 1 by c. Integration of dt is 1 by s. and I of t becomes I of s, because I will written t equal to s. So I of s equal to Cs V naught of s, equation number 2. So ultimately I of s is intermediate output. So I am not interested in the intermediate output, I am interested in the final output, so that I will substitute equation 2 in 1. If I substitute equation 2 in 1, so Vi of s equal to Cs V naught of s RCS plus 1 divided by Cs. So Cs get cancelled, I will get V naught of s divided by Vi of s equal to 1 by RCS plus 1. This is called our transfer function. So you see here, the transfer function is the mathematical modeling of a RC circuit, and it correlates between output to input. I'll put the input, variety of inputs are there. It may be step input, it may be ramp input, it may be parabolic input, it may be impulse input, it may be sinusoidal input. Then I'll get a output. So that we'll learn in the next chapter. That is called time response of first order system as well as second order system. You see here, the highest power of s in the denominator is 1. You see here, the highest power of s in the denominator is 1. So that it is called, you don't see the numerator, you see the denominator. It is called what? First order system. First order system. If it is 2, then the second order system. If it is 3, third order system. If RLC circuit is there, that automatically becomes second order system. And I'll take RC is equal to time constant. One constant, because R is constant, C is constant, I'll get RC circuit. So V naught of s, Vi of s equal to 1 by Ts plus 1. 1 by Ts plus 1. This is called a standard form of first order transfer function also. Okay. So like this, we'll come to know that what is the Laplace, what is the use of Laplace, how we have to apply the Laplace, and how to find a transfer function. Without Laplace, we cannot find a transfer function. And once we know the transfer function, then what is the use of transfer function? Is to find a time response. Because time response is very important. At first second, what is the output? Second second, what is the output? Third second, what is the output? Fourth second, what is the output? We'll find. So this is one good example, basic example of a RC circuit. Like this, the first order, the water tank system is there. First order, and RLC circuits are there. So many, and some are electromechanical system. Input is electrical, output is what? Mechanical. Here the electrical input, electrical output. And some are mechanical input, spring mass system. You are applying a force with the mechanical. Output is what? Displacement. That is also mechanical. Some are mechanical input, mechanical output. Some are electrical input, electrical output. Some are thermometer. If you take a thermometer, heat is the input, output is a displacement of what? Mercury. So like this, variety of examples we'll see in the next lecture. So in this lecture, I hope you understood what is a Laplace transformation and different types of formulas, and what one typical example is RC circuit, that is a first order system. The order of the system also will come to know that what is the order of the system. Okay, thank you.